Hey everyone, I went and made a long 36-minute video on triangles and realized I made two goofs in it, so here we go again. A lot of students have reached out and said that they're struggling with geometry, okay, and it seems like triangles and circles are the very specific areas where the trouble is happening. So I'm going to do a quick overview of triangles here. If this video is not quite enough for you, first thing you need to do is start joining the Zoom meetings, okay? Almost nobody's coming to Zoom. But when you come to Zoom, if you have questions, you've got to come with questions, okay? So what we'll do is, if you're struggling with something, be ready to pull up EdReady, and then we can go over specific problems that you're struggling with in EdReady. And I can give you overview information, but come to Zoom, ask questions, come with specific questions from your EdReady. We can do that, but otherwise, if that's not enough, or if you need something a little more specific, I can make these videos, but you got to tell me what you need, okay? So let's start with triangles. Okay, so I just got a weird video. Okay, anyway, so what we want to do here is look at a triangle. So everybody knows what a triangle looks like. It's a polygon. It's a flat enclosed figure made up of three sides, and it's made up of three angles. So these inside areas, these are the angles. And what you need to know is if I take A plus B plus C, it's going to equal 180 degrees. Okay, so if I were to give you a triangle like such, okay, I could say that this is 96 degrees. I could say that this is 41 degrees, and then I could say, okay, what is X? Well, we know that the three angles of a triangle have to equal 180 degrees. So we start with 180, we subtract 41, we subtract 96, and we are left with 43 degrees. So we could say X equals 43 degrees. That's like one of the most basic and fundamental ideas of a triangle, is that the three angles have to add up to 180. All right. Now, you can have different types of angles. And I do want to go over the types of angles really quick, just because some of this terminology is going to come up in a bit. You can have an acute angle, and it's an angle that is less than 90 degrees. All right, you can have a right angle, and a right angle is exactly 90 degrees. All right, you can have an obtuse angle. An obtuse angle is more than 90 degrees, but less than 180. And then you can have what's called a straight angle. And a straight angle is equal to 180 degrees. So an acute angle is a little skinny angle. A right angle makes up like a perfect corner, like the corner of a square or a rectangle, and you always denote it with like a little box in the corner. An obtuse angle is nice and wide, like this. And then a straight angle actually looks like this. All right. So the words acute, right, and obtuse, they're going to come up, kind of throughout this video, okay? So I wanted to make sure you knew what we were talking about. All right, types of triangles. Whoops. All right, we're going to talk about 4 types of triangles. The first type is called an equilateral triangle. All right, the 3 sides are the same, or we would say congruent, and the 3 angles are the same, or again, we would say congruent. So the way we denote that the sides match or they're the same, we put these little tick marks through them. And if they all have the same tick mark, that means they're congruent. And then the same thing with the angles. A lot of times you'll do angles with tick marks, or you'll do angles with like these little curves. And if they all have one curve, that means they're the same. Okay, so a lot of times we'll use curves like within maybe two triangles. If we're comparing two triangles, you'll see like one curve in one triangle and then one curve in another triangle. That indicates that those angles match. And then if we did like a double curve, the two angles that have the double curve would match, and then you could do a triple curve. But here, because all three of these angles are going to be the same, we're just going to use a single curve in each angle. All right, so we know that triangle, the three angles have to add up to 180 degrees. If we divide that by 3, we get 60. So the three angles of an equilateral triangle would be 60 degrees each. Okay? Next up, let's talk about a right triangle. Now, right triangles actually come up a bit more depending on the classes you take. They have some special features, but we're just going to talk basics. So a right triangle, let me try that again. A right triangle is going to have a right angle. So it's going to look like this, and the right angle, again, is the one that makes the corner of like a square or a rectangle. Now, when you're dealing with a right triangle, the side that is opposite the right angle, this longest side of the triangle, this is called the hypotenuse. And then the two sides of the triangle that make up the right angle, those would be called the legs of the triangle. All right, now because you have this 90-degree angle, the other two angles have to be acute. So when you're dealing with a right triangle, that one angle is 90 degrees and the other two angles are acute. So the other two angles here and here, if they're the same, they would both be 45. If they're different, they could be, 30 and 60 or something that adds up to 90 degrees. Okay? Next up, we have an isosceles. Now, generally speaking, two angles are congruent and two sides are congruent. So you'll have a third angle and a third side that don't match the other two. So within the realm of isosceles triangles, you actually have kind of three different types. So you can have an isosceles acute. Okay, in an isosceles acute, you have three angles that are acute angles. Okay, so all three of your angles are going to be less than 90 degrees. So you could have something like this. The two sides that I put the line through are congruent, and then the two angles that I measure with a curve are congruent. And basically, all three of your angles would be less than 90 degrees. So we could have 80 degrees, and then 50 degrees, and 50 degrees. That would be an example of an isosceles acute triangle. Okay, you've got two angles that match, two sides that match, and then all three angles are less than 90 degrees. Now, you could have an isosceles right triangle, and that's going to look kind of similar to what we had on the previous page. You have your 90-degree angle, and then these two angles have to match. Okay, so I'm going to put the single curve in there to indicate they match, and we can figure out what those two angles have to be. We've already taken 90 degrees for that right angle, so that leaves 90 degrees for the remaining two angles, and they have to match because this is an isosceles, so we divide it by 2, and these two angles right here both have to be 45 degrees. Okay, so an isosceles acute, all three angles are acute. They still have to measure 180. So you've got the two angles that match, 50 and 50, and then the 80 degrees, all less than 100 or all less than 90 degrees, and the three angles add up to 180. With an isosceles right, you've got one 90-degree angle. The other two angles have to match. That means they have to be 45 degrees each. And then finally, we can have an isosceles obtuse. And it's going to look like this. So you can see you have this one obtuse angle at the top, and then you've got the two sides that match, and I indicate that with a little tick mark in the sides, and then the two angles match. They each have a single curve. So let's say this top angle is 100 degrees, okay? We know a triangle has to have 180 degrees, so whoops. So I subtract the 100 degrees that I've already used. That leaves me 80 degrees to split between the two remaining angles. So the two remaining angles would be 40 degrees. So an isosceles acute, all three angles are less than 100 or are less than 90. Bless my heart. With an isosceles right, one angle is 90, the other two have to be 40. With an isosceles obtuse, one angle is greater than 90, the other two are obviously going to be less than 90, and they have to match. But at the end of the day, all three angles have to add up to 180. Next up, we have scalene triangles. And there are no congruent sides or angles. Oops. So no two angles are the same, no two sides are the same. So just like with the isosceles, you can have a scalene acute. So something like this. Let's say this is 75 degrees. This is, let me come up with good ones. Whoops. We could say this is 50 degrees and this is 55 degrees. This is an example of a scalene acute. No two angles match, no two sides match, and all three angles are less than 180. You could have a scalene right triangle. So something like this. And let's say this angle is 60 degrees and this angle is 30 degrees. So no two angles are the same, but in a scalene right, you do have the 190-degree angle, and then the other two angles are going to be some other value that adds up to 90. And then you could have a scalene obtuse, and that would be something like this. We could say this is 100, this is 50, and this is 30. Okay, so you have one angle that is obtuse, greater than 90 degrees, and then you have the other two angles. Let me make this look better. It looks like 300. And then you have the other two angles that are acute, and the sum of the three angles would add up to 180. So you've got equilateral triangles, right triangles, isosceles triangles, and remember, isosceles acute, isosceles right, isosceles obtuse. And then you have scalene triangles, scalene acute, scalene right, or scalene obtuse. All right. Now, next up, we need to talk about, whoops, I didn't mean to do that. We need to talk about congruent triangles. So congruent triangles have corresponding sides that are congruent and corresponding angles that are congruent. All right. So let's look at examples right here. Okay. So let's say that I have these triangles here. Let's say this is 20 degrees, this is 120 degrees, this is 40 degrees. And notice these tick marks, they're going to make sense in just a little bit when I show you the next triangle. pretend that's a perfect triangle again. Okay, so the two sides that have the 3 dashes, oh, I messed up my dashes, hold on. Did not mean to do that. Good grief, let me just start this one over. I'm not very good at drawing these. Okay, let's start again. Okay, that's better. So notice that the 3 angles in the first triangle are 40, 20, and 120. The 3 angles in the second triangle are 40, 120, and 20. So you can already tell that the angles match, and then the sides also match. And you can see that the side that makes up the 20-degree and the 40-degree angle has 3 tick marks. And then on the second triangle, the side that makes up the 40-degree and the 20-degree angles, 3 tick marks. The side that makes up the 40 and the 120 in both triangles have 1 tick mark, and the sides that make up the 20 and the 120 both have 2 tick marks. So watch these figures closely and look for matching tick marks and look for matching angle curves, okay? So these triangles are congruent. Everything matches, okay? Now, the next thing is similar triangles, and you have to do a little more work with similar triangles. Similar triangles are the same shape. So if you're dealing with equilateral triangles, you have to have 2 equilateral, or you have to have 2 isosceles. And within isosceles, they both have to be isosceles acute, or isosceles obtuse, or isosceles right. And same thing with scalene. You can have 2 scalene triangles, but they both have to be scalene acute, scalene obtuse, or scalene right. The thing with similar triangles is that they're different sizes. All right, so what this means is the length of the sides, so the length of corresponding sides have a proportional relationship, and we'll talk about that in just a second. And then what's interesting, because these are the same shape, the angles, the corresponding angles have the same measure. So they're different sizes, so the length of the sides of the triangle are going to have a proportional relationship, but the corresponding angles are actually going to be exactly the same. So let's look at an example of that. So let's say that my first triangle here let's say this is 6, 9, 7.5. Right, and let's say I have this one. And we have 4, 6, and 5. So you really have to pay attention here. You can kind of easily tell the sides that match when you're dealing with a scalene, because you have the smallest side, the middle side, and the longest side. So I can tell here that on the larger triangle, the smallest side is 6, and it corresponds to the smallest side of 4 on the second triangle. So I'm going to do larger triangle compared to smaller triangle. The middle side on the bigger triangle is 7.5, and that's going to correspond to the middle side on the smaller triangle. So I get 7.5 to 5. And then the longest sides correspond, which would be 9 to 6. Okay, so you can see the corresponding sides here. But what we also need to look at is the ratios, okay? So we have the ratio of the bigger triangle to the smaller triangle, looking at the corresponding sides, and let's simplify each of these. So you can either simplify the fraction, leave it in fraction form, or you can write them as a decimal. But when I do this, the first ratio simplifies to 3/2, the second ratio simplifies to 3/2, and the third ratio simplifies to 3/2. So if the ratios of corresponding sides are the same, the two figures, in this case the two triangles, are similar. So if the ratio or the ratios of corresponding sides are all the same, then the two fractions, the two figures, then the two figures are similar. And notice the angles. So the smallest side and the largest side, the angle that is made up by the smallest and largest side, they're going to end up being congruent. And I've labeled it with the double curve. The side, the shortest side and the middle side, the angle that's made up by the shortest and the middle side, they're going to be the same from one triangle to the next. And I've labeled those with a single curve. And then the middle side and the longest side, the angle that's made up by the middle and the longest sides, that's going to be congruent from one triangle to the next, and I've labeled those with the triple bars. Okay? Does that sound good? I hope so. All right. Let's look at another one. All right. So the last thing I really want to look at is finding a missing side of similar triangles. So finding a missing side with similar triangles. All right, you do a lot of this in your Ed Ready, so make sure you kind of understand this concept. Basically, what you want to do is you want to set up a proportion with two sets of corresponding sides. So let's consider, let me look at an example. Let's consider this one. So let's say our first triangle is PQR. It is a right triangle, and it's fully labeled. And that's kind of the thing here. When you're finding a missing side with similar triangles, one of the triangles has to be pretty well labeled, okay? Or you at least have to have two sets or two sides that are labeled. And then let's say this is my similar triangle. Notice they're the same shape, certainly different sizes. And this is going to be X, Y, Z. Now notice angles P and X correspond to one another because they're both 90 degrees. And then notice angles R and angle Z. I've labeled them with a single curve. That means those two angles correspond. So by default, Q and Y, those angles would also correspond. So let's look. Let's say that we have the side XZ, which is 24. But I want to know what the angle YZ is. So I've labeled it with an, well, I'm going to label it with an N. All right. I can easily find the side because I know that this triangle is similar to triangle PQR. So what I want to do is I want to take this given side right here, and I want to find its corresponding side in the other triangle. So the corresponding sides would be PR, which is 12, and then XZ, which is 24. So I'm going to set up a ratio of the smaller triangle to the larger triangle. And then I need to look at the missing side, the one I'm trying to find, which is YZ. Well, YZ corresponds to QR. So I want to set up another ratio of smaller triangle, so QR, to larger triangle, YZ. Now I just have a regular proportion that I can solve. So I'm going to solve it over here on the right. I cross multiply and I get 12n equals 13 times 24. So 13 times 24 is 312. And then I need to undo the multiplication of 12 and n. So I divide each side by 12. And 312 divided by 12 is 26. So that means this missing side, yz, is 26. All right. So basically, when you have two similar triangles, you can find missing sides of the triangle by setting up a pretty simple proportion. All right. So this is the very basic overview of triangles. We didn't go deep. It quite literally is just an overview. Let me know if this isn't quite enough. The best thing you can do is join Zoom. Okay. When you join Zoom, come with specific questions or specific things you need discussed. So you can't just say, well, I'm stuck on triangles. Say, you know, I'm stuck on finding a missing side. It's even better if you have Ed Ready open and ready with specific questions that I can help you with. But please start joining Zoom. That's the best way to get help, okay? Second, if you need a little bit more intense help, I can make more videos, but I need to know what to put in the videos, okay? So you guys have to really go through Ed Ready, take notes on what you're struggling with, and let me know, and I can make these videos, okay? So if you need anything, just let me know.